Household energy reduction and self-generation typically exist within a narrow set of approaches. Most rely on physical infrastructure, grid dependence with variable pricing, on-site generation systems such as solar arrays, wind devices, fuel-based generators, or hybrid storage configurations. Each approach introduces a recognizable cost profile that extends beyond initial purchase. Upfront expense is only one component. Installation permissions, structural compatibility, electrical integration, maintenance schedules, and regulatory compliance often accumulate gradually, rather than appearing at once. Systems that promise simplicity frequently relocate complexity into planning stages, documentation, interpretation, or long-term monitoring. Attempts to simplify energy generation commonly reduce visible steps while increasing implicit responsibility. When hardware is removed, interpretation increases. When automation is reduced, manual oversight expands. When professional installation is avoided, liability shifts to the user. Instruction-based alternatives tend to emerge in response to these pressures. Rather than supplying finished equipment, they provide information intended to guide independent construction or experimentation. These approaches reduce manufacturing and shipping constraints, but they also remove enforcement, standardization, and external validation. In practice, the failure pattern is not usually immediate malfunction, but misalignment between expectation and operational reality. The system does not fail mechanically. It fails structurally when responsibility exceeds the user's tolerance for ambiguity, decision-making, or sustained attention. It is within this landscape, between turnkey systems and open-ended experimentation, that instructional energy products are positioned. The Energy Revolution system is a digital instructional product. It is not a generator, a physical device, or a pre-assembled unit. Its core offering consists of documentation, written guides, diagrams, and explanatory materials describing a conceptual energy-related configuration. Delivery occurs digitally. Access is provided to files rather than equipment. No components are included, no tools are supplied, no physical system is shipped or installed. The scope is bounded to explanation and illustration. The product outlines a proposed configuration and references historical or conceptual material to frame that configuration. It does not attempt to provide certification, testing data, or standardized performance metrics. What it explicitly does not include are finished assemblies, automated safeguards, professional oversight, or site-specific adaptation. There is no mechanism within the product that accounts for regional electrical standards, building codes, grid interconnection rules, or safety certification requirements. Structurally, it functions closer to a manual or experimental guide than to an appliance or energy service. Use begins with interpretation. The materials must be read, understood, and translated into action without external enforcement. Time is required not only to review the content, but to reconcile it with available tools, parts, and local conditions. Interaction is intermittent rather than continuous. Engagement occurs during reading, planning, sourcing, and assembly phases. Between these phases, progress depends on external availability of components and the user's capacity to coordinate them. Preparation involves identifying materials independently. This includes determining equivalence, assessing quality, and resolving substitutions when exact components are unavailable. The product does not manage this process. Repeatability is not inherent. Each build attempt is context-specific, influenced by sourcing variability, environmental conditions, and interpretation differences. Outcomes, if any, are not standardized across implementations. Environmental dependency remains external. Electrical characteristics, load behavior, and integration constraints are not mediated by the product. Any interaction with existing systems occurs outside its scope. The format assumes tolerance for iteration without feedback loops beyond the user's own observation. Cognitive friction appears first. The material requires interpretation. Concepts must be understood well enough to inform physical decisions. Ambiguity is not resolved by the product. It is managed by the user. Logistical friction follows. Components must be located, evaluated, and acquired independently. Availability varies by region. Substitution decisions introduce additional judgment calls not addressed by the documentation. Technical friction emerges during assembly and integration. Physical construction, wiring considerations, and compatibility with existing systems are not automated or verified. Errors are not intercepted by design constraints. Regulatory friction remains fully external. Compliance with local electrical codes, safety standards, zoning laws, or inspection requirements is not addressed. Responsibility for legality and safety does not transfer. Ongoing operational responsibility persists after any initial setup. Monitoring, adjustment, and troubleshooting are not supported by the product. There is no adaptive mechanism or update path tied to real-world conditions. These layers do not resolve into a single task. They accumulate sequentially. This structure tends to align with individuals comfortable operating, without validation or standardization. Those accustomed to interpreting technical material and managing uncertainty may tolerate the absence of enforcement mechanisms. It is commonly rejected by those who expect predefined outcomes, regulatory clarity, or externally managed risk. Users seeking installation services, guarantees, or measurable benchmarks typically disengage early. Some prefer more complex systems with professional oversight, despite higher cost, because responsibility is redistributed outward. Others avoid such systems due to financial or structural barriers, even when they reduce decision burden. The divergence is not based on interest in energy reduction, but on tolerance for unresolved responsibility. Within the broader energy landscape, this product occupies a position distinct from equipment-based systems and from professional services. It does not compete on automation, certification, or integration depth. It reduces entry cost by removing physical delivery and external labor, while increasing interpretive and operational responsibility. Depth, customization, and control are not optimized. They are constrained by format. It does not replace grid systems, certified generators, or engineered installations. It exists alongside manuals, schematics, and experimental documentation, trading external structure for internal decision-making. The boundary remains at instruction. Beyond that boundary, responsibility does not migrate